And we're back for another daily space weather. Thanks for tuning in. We're looking at some sunspots here. Sunspot 2835, sunspot 2836, and 2837, which is this one. 2836 is this one down here, and 2835 is this one here, the largest. As forecasted, we've seen the X-ray profile drop off. It's called the Earth facing quiet. The radio flux came up. Lots of filaments between the Earth and the Sun, an increase in geomagnetism, and more in today's video. Here's 304 angstroms ionized helium to see some rather flat filaments. So there are a lot of filaments on the Sun right now. You can see some of them hanging off the edges as prominences out here and out here. And there are additional filaments all around these series of active regions. Let's take a look at the colorized magnetogram to characterize the sunspots. Sunspot 2835 has quite a large leading umbra there. Both of these two are beta class. This one up here is alpha class, which makes it less likely to produce solar flares. And the Earth facing quiet makes these less likely to produce significant solar flares, at least ones that are detectable from Earth or at Lagrange point 1. They've stayed mostly stable here over the past 24 hours. Here's a diagram of the solar system. There's where things will be in a week on 7/7. And here's a star chart. We show it daily. You've got the Moon, Jupiter, and Saturn up there if you're up before dawn. I face mine to the south. This yellow line is the ecliptic, the path the Sun will take across the sky. Speaking of the Sun, the radio flux is now at 93, so a precipitous uptick here as forecasted in the 10.7 centimeter radio flux. The most proportional data set to sunspot number. So here it is in the context of a one-year chart from Solon.info. And welcome to the latest uptick here in cycle 25. So we haven't seen this high of a level of radio flux since December of last year. The red line down here is the sunspot number. No solar storms or anything like that forecasted. We're on the Space Weather Enthusiast dashboard. We did see some incoming space weather, and we'll explain why it's so geo-effective in a moment. First, some global seismicity information. There is an earthquake lull going on right now, a massive drought of 7 magnitude and larger earthquakes. As you can see from this 90-day chart, check out what the year 2020 looked like. All those red bars are 7 magnitude quakes. We've only seen one over the past 90 days. So if you're in an earthquake-prone zone, please have a disaster plan, as earthquake droughts end in earthquakes. So we're going to just ignore this, as it looks like some things got downgraded, and I'm not going to really worry about it too much. But here is the USGS site. We're just going to scroll up the list here. The USGS site and volcanodiscovery.com not agreeing here, as volcanodiscovery.com showing 3 5+ magnitude earthquakes, USGS showing 0 5+ magnitude earthquakes. There was at least one deep quake there near Fiji, as well as one at Mexico, those both in the mid-4 magnitude range. Kansas saw a rare 2.9. We saw a 4.0 off the coast of Oregon. A 4.6 at depth in Indonesia, followed by a 4.8 at depth at the Philippines. That coming in a half hour before midnight. 4 magnitude deep quake at Chile. Again, folks, earthquake lulls end in earthquakes. See that chart? We are well overdue for a 7 or even a larger earthquake than that. Let's talk about volcanoes. Here's Mount Merapi, which produced some phoenix clouds in the past 24. Let's see what else is on the list. Subanose Jima, flight level 080, as it's exploded and produced an 8,000-foot plume of volcanic ash. And there's the write-up on Merapi. There's a lava dome collapsing, which could provide additional fuel in the form of silica Also, block and ash flows continue to descend over the southeast slopes, reaching a length of at least 2,000 meters and 1,200 meters, respectively. Some incandescent avalanches as well. Pyroclastic flows are mentioned. By the way, pyroclastic flows are deadly, turbulent, hot avalanches of lava rock fragments of all sizes embedded in a mixture of turbulent gas and ash racing down slopes. Let's hope you never experience one. Semeru on East Java exploding. Flight level 130 there. It's a 13,000-foot ash plume. Don't hang glide over Dacono. It's got a flight level 070 as it's producing a 7,000-foot ash plume of volcanic ash. Revenador exploding, 15,000-foot plume of ash over Ecuador. Down to Peru. Sabancaya exploding, producing a 24,000-foot ash plume. And while we're unable to detect Nevados de Chilean's activity, please do not take it as an opportunity to pole vault the caldera, as it could be erupting. It could be a cloudy day where the caldera is not visible in the satellites, and you're probably not Steve Stimpak. So don't pole vault the caldera. This public service message brought to you by smAsho.com. Visit our website, support our channel via our links. And as we forecasted, we've seen a bit of a downtick here in the X-ray profile of the closest star. No real surprise there, as the most major sunspots are moving into the Earth-facing quiet zone. Anyway, there's a 3-day chart of the GOES X-ray flux. No spikes in the proton flux, as no high-energy protons have arrived recently. Let's take a look at the heliospheric current sheet. And those sunspots in the southern hemisphere are delaying the arrival of the South Pole current sheet. They're holding back the magnetic field, so to speak. Keep in mind this data is 1 hour old and can change with absolutely no warning. The South Pole current sheet is on the way, so if sunspots suddenly degrade, Earth will suddenly be in a South Pole current sheet. That's all I'll say about that, as I'm fairly careful with my lingo to not make a fool of myself or my viewers. Here's a line of sight ecliptic plane field plot. And you can see the solar magnetogram there, the way it's sort of affecting the current sheet. And this shows the North Pole current sheet in green, the South Pole current sheet in red, the same as the last imagery. The line of sight ecliptic plane field plot. And here's the line of sight coronal hole plot. And we see some trans-equatorial south-oriented coronal holes and some stretching down toward the equator there, north-oriented coronal holes. They're mixing it up around the equator here, just south of sunspot 2837, which is right about here. So some added magnetic complexity kicking off there. And here's some more imagery for you. The breakdowns of sunspots 28, 35, 36, and 37. And it's not actually detecting any coronal holes on this. That's okay. We just showed you the coronal holes. And once these move out of the Earth-facing quiet zone, if they stay as they are now, you can expect some significant solar flares. Don't be surprised to see an M-class flare from one of these sunspots when they're over in this area. Give it about 2 days. And if they stay stable, expect an uptick in the X-ray flux, otherwise known as solar flares. So here's the KP index, a measurement of global geomagnetism over the past 3 days. And the KP index currently at 2. It's pretty calm conditions. Next, a real-time solar wind. And what we've seen here is the BZ. The BT-BZ has suddenly diverged from the zero line. So you can see the BT made it all the way up to about 10, and the BZ at -9. So that is a more effective magnetic regime than what we did see. And the shift in the BZ there is the most important factor there. So the total field increased, and we're seeing strong south polar field-oriented magnetism, as well as a small uptick here in the solar wind speed and density. So this looks like a small coronal mass ejection strike. It's slow speed. So this would have happened several days ago, like 3 days ago, 4 days ago. So we saw this small uptick here in the solar wind density and speed at the same time as we saw a huge shift in the BTBZ. And that's why there have been some auroras kicked off and so on, some ground geomagnetic perturbations. We'll show you that in a moment. Current conditions are about 16.5 protons per cubic centimeter for the solar wind density. Solar wind speed 348 kilometers per second. Not very fast at all. It's a slow speed coronal mass ejection that would have occurred about 4 days ago. Here's the magnetohydrodynamic pressure over the past 4 hours. And we see elevated pressure here, mainly as a result of the shift in the BTBZ, not so much in the solar wind density. The shift in the solar wind velocity was practically irrelevant. The density does make a difference, but the change in the magnetic field regime is the main factor in this increased magnetohydrodynamic pressure. We're also seeing ground magnetic perturbations having increased here, and we'll show you the aurora forecast on the next frame. So this is the polar view of geospace delta B, changes to the Earth's B field, giving you some insight as to where the geomagnetic poles are located. And here's the full planet view, the flattened view that we show daily. When we get more activity, we show the polar view. I did notice one perturbation here around Madagascar, the African Rift Zone. Little pulse there coming out of the western Indian Ocean. So some significant magnetic perturbations here caused by mainly that shift in the BTBZ. Here's the auroral forecast as magnetism by itself without even a significant particle induction from solar wind. Just a magnetic shift can cause auroras to spark off. And we figured we'd show the data here. The aurora forecast. And you can find all of these links on any of the Space Weather Prediction Center websites. There's a huge series of links at the bottom. Now, we do regularly stream live to Twitch, and we're going to for our cosmology segment. Make sure you check that out, as it will be a separate video today, our cosmology segment. Also check our playlists, youtube.com/smashamash/playlists. And we just recorded a cosmology segment. Let's get back to the daily space weather. We're going to talk about electrons as they have the capacity to charge up satellites, cause communications errors, and so on. And we've seen a little uptick here in the electron flux. So we see some minor charging hazards over places like the Caribbean, the northern portion of South America, and moving into the central Pacific area, all north of the equator there, some surface charging hazards seen. Here's the one-year chart of the electron flux from solon.info. Still in moderate levels. Here's a 3-day chart. We haven't reached warning levels or anything like that over the past 3 days. Here's the forecast for the electron flux. And we're expecting the same levels here tomorrow, at least NOAA is. I have no reason to argue with that forecast. Here's the total electron content, showing you the entire electron density for the whole air column, all the way up to where your GPS satellite's located at tens of thousands of miles of altitude, all the way down to your handset. This gives you ideas of where GPS errors may happen. And we're seeing some anomalies down here in the Antarctic region. So if you look around the Antarctic continent, you can see some high-density areas here of electron flux. Areas south of South America, south of the Atlantic Ocean, and a little bit south of the Indian Ocean, some anomalous electron flux levels there. Also some very high levels of electron flux over the Atlantic Ocean. And since it refreshed, we'll let it play through a second time here, as we've got some activity going on with the electron flux. Probably sparked by the changes in Earth's magnetism, probably sparked by changes in the BTBZ, which we showed you earlier in the video on the solar wind components. So here's a diagram of the atmosphere showing you Van Allen belts and distances in miles to satellites. Next, we're going to look at the F ionosphere layer. If you're wondering what that is, it's this little slice of the atmosphere here, located at about 300 kilometers. It's largely the bridge between space and Earth. All your weather comes from space, folks. And here is some data about that. It's the vibrational frequencies of that 300-kilometer F ionosphere layer. And we're seeing some anomalies here once again off the west coast of South America. So if you watch this area down here, you'll see surprisingly high vibrational frequencies here. We would expect that north of the equator here in northern hemisphere summer, but that's what we call an anomaly. So here's the latest image coming through at 8:45 Universal Time. Things looking fairly normal at that moment. And again, the FI ionosphere located at about 300 kilometers of altitude. And if you haven't checked out our meteorology segments, check that out as well. We've been making them separate videos most days. And here come daily space weather bonus features in the form of the most recent hydrogen alpha imagery from El Teide, Spain's ground-based observatory. And I would note massive filaments here. So these are pretty flat filaments. They're not really out very far into the corona, but you can see filaments here, dark spots here. Those are all filaments, also filaments up here. So there is a significant possibility for coronal mass ejection. Here's more filaments. So lots of filaments right now between Earth and Sun. They're not particularly far out suspended in the corona. I'll just leave it at that. Here is the thematic map. Let's shrink that down a little bit here. There we go. There's the thematic map from the GOES 16 SUVI. And you can see some of those filaments shown there in the dark orange color. Also some lots of prominences actually. So lots of plasma hanging around in between Sun and Earth right now. I'm not going to make a coronal mass ejection watch. Not this time. But there is always some likelihood of coronal mass ejections. Continuing on. And here's the current sunspot situation. Sunspot 2835 has grown in terms of its leading umbra. So that umbra's gotten bigger. Sunspot 2836 has remained mostly stable, as well as Sunspot 2837. Earth-facing quiet effect going into effect. And let me just press refresh here to make sure we have the latest data. There's the latest imagery in magnetogram. And here's a 48-hour. So we actually did a 48-hour video this time. This is a 48-hour SDO video in 94 angstroms. It's one of the best wavelengths in that it shows you 10 images per minute instead of only 2. So 94 and 131 angstroms show you 10 images per minute. They're specifically formulated to watch things like solar flares and coronal mass ejections. You can see some brightening there, some minor flaring out of especially Sunspot 2836 and Sunspot 2835. And that's today's daily space weather video. Congratulations once again on finding our channel. Don't forget to press like and subscribe if you enjoy the content, and may that solar wind be at your back.